In this video, we're going to do something called deriving the quadratic formula from the standard form of a quadratic. So basically what we're going to be doing is we're going to be trying to find out how they discovered this very interesting x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, which a lot of people remember, from this form here, which is the standard form for a quadratic equation. Okay, so how did they get from here to here? And that's what I'm going to show you in this video. Basically what we're doing here is we're taking this equation and we're solving for x. Okay? And we're solving specifically, if we're solving for x, you're trying to solve for where the parabola, because remember quadratic formulas, or quadratic equations rather, produce parabolas. So where does the parabola cross the x-axis? So what are the x-intercepts? That's what this means. And where it crosses the x-intercepts, the y is 0. So in our first step, this is what we're going to do. We're going to say ax squared plus bx plus c is equal to 0. Because again, if you were to look at your parabola like this, and again, we're trying to solve for where this parabola crosses the x-axis. That's what the x is. At the x-axis, y, here's the y-axis, y is equal to 0. So that's what we're solving for. Okay, so we're going to do this process by doing something called completing the square. Okay, let me just write that in there real quick. So if we're going to complete the square here, we've got two things we need to do. We need to make this side of the equation a perfect square trinomial. Okay? And do you remember what a perfect square trinomial is? Let me just write this down here. A perfect square trinomial is something that looks like this. Like, for example, here's one of the simplest ones. It's x squared plus 2x plus 1. And a perfect square trinomial is when both of the factors are exactly the same. So for example, this is x plus 1 times x plus 1, or x plus 1 quantity squared. All right? So we want to make this side of the equation a perfect square trinomial, something times itself equal to 0. Now when I look at this, I have a couple of problems. If you look at this really easy one, you'll notice that there's no number in front of the x squared. And here we've got an a. So one of the first things that we want to do is try to get rid of that a. And how would we do that? Well, the best thing to probably do is to divide by a on both sides. All right, so that's what we're going to do in that step. Now, remember that this is the denominator for each of these terms. So ax squared divided by a, the a's cross out, and you're left with x squared. Bx over a is still just bx over a, and then c over a is just still c over a, and 0 divided by a is still just 0, because any number, 0 divided by any number is still going to be 0. So now we've got this. Okay, so we're getting closer to having a perfect square trinomial. Now again, what do we need to have a perfect square trinomial? That has to be a perfect square, but so does this value here. So does the c, or the constant, needs to be a perfect square. Again, I would have you look over here for just a second. We know that's a perfect square trinomial, and the way you do that is you take the square root of that, the square root of that, the square root of 1 is just 1, the square root of x squared is just x, and then you put the sign from here and then square it, and that works. Let's try it again with a different perfect square trinomial, something like, let's say x squared plus 4x plus 4. Again, what's the factored form of this perfect square trinomial? You take the square root of that, the square root of that, and then use the sign in the middle. And again, there's the answer. And if you look at the next one up, you just start to see a pattern. Okay? So take the square root of that, square root of that, take the sign in the middle, and again, there's the factored form. Oops, sorry. There we go. It's a little bit off camera there. So you see what the pattern is. This needs to be a perfect square, and so does this. and then when you multiply them, you get that, but when you add that, you'll get that. So we got the same situation going on up here. If I want for this to be a perfect square, I need to have something that I know is a perfect square, and c over a doesn't look like a perfect square to me. So we're going to complete the square to make this happen. We're going to go x squared plus b over a times x plus something is equal to a negative c over a plus something. In other words, we just move this over to this side and try to figure out what the perfect square is that needs to go in here. Now, how do you do that? Well, the process that you can use is you take half of this coefficient and square it. So you want to take, sorry about that, you want to take half of b over a, and then square it. Now, what is half of b over a? Well, if you remember your fractions, b over a times, or divided by 2 over 1, is the same thing as saying b over a times 1 over 2, and that turns out to be b over 2a. The other way you can look at that is just to say b over a times 1/2, and again it's b over 2a. And you get the same thing. Now what we have to do is square it, right? Because we want this to be a perfect square. And when you square it, you're going to get b squared, square the 2, square the a. Because, remember, difficult problems are just a bunch of simple ones stacked up together. And that's what goes into this space right here. B squared over 4a squared. All right. So we've actually completed the square. All right. Now what do we need to do? We need to factor this. Just like we factored these over here, this is a perfect square trinomial, and you want to factor this too. And remember how we did it. You take the square root of x squared. You take the square root of b squared over 4a squared, which would be b, because the square root of b squared is b. Square root of 4 is 2. Square root of a squared is just a, and then you take that sign, and sure enough, there it is. And if you foiled this, you would get that. Now on this side over here, we're going to add c over a plus b squared over 4a squared. Now, a little tricky. How do you get these to be the same? You have to find this common denominator, don't you? So what we're going to do is multiply this side by 1, and what's missing here is 4a over 4a. There's my 1, but look what's happening. All of a sudden you've got a minus 4ac, doesn't that look familiar? Plus b squared over 4a squared common denominator. So I can just put it all under 1. Okay? This is starting to look a lot more now like our quadratic formula. Okay, now we're getting close. Again, we're solving for x, so what the next step is going to be is to take the square root of this side because you want to get rid of the square. So I'm going to have x plus b over 2a, quantity squared, and take the square root of that. Do the same thing on this side. Okay, let's move that up a little bit. Once I take the square root of this squared part, it just makes these guys go away, and I get x plus b over 2a. Now on this side, we're going to have to take the square root of this very complex fraction, but what we can do here is actually just take the square root of the top part, and oh, by the way, since this is an addition, I can flip these back and forth, right? I can just say b squared minus 4ac, and remember what does that is called the commutative property. You can actually flip those around. Over the square root of 4a squared. But what is the square root of 4a squared? It's just 2a. And this one we don't know because there's an addition and subtraction up there, so we just have to leave it alone. So it's b squared minus 4ac. All right, we're getting close now. So now I've got x plus b over 2a is equal to the square root of b squared minus 4ac all over 2a. Our answer is almost here. By the way, when you take the square root of something, don't forget you get the plus and the minus value there, all right? We're almost done. Step 9. Let's subtract b over 2a from both sides, and you end up with x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac, again all over 2a. And since those are common denominators, in my last step I'm just going to clean it up. X is equal to negative b plus or minus the square root b squared minus 4ac all over 1 common 2a. And there's your answer. So look what we've done here. I'm just going to do this, change my focus on this just a little bit. We have actually derived the quadratic formula from the standard form just by completing the square. And those are my steps. Okay? So we completed the square. Sorry, let's put this in focus there. We're completing the square. We created a perfect square trinomial on this side. Gave some examples here. We factored that. We added 2 fractions by multiplying by 1, got a common denominator. We square rooted both sides because we want to get rid of that square, again solving for the x. Subtracted b over 2a to this side, and it ended up being exactly the formula that we all have memorized. Okay, I hope that was helpful to you. You can look at this as many times as you need to.